Hello, and in this video we're going to have a look at static routes on Juniper, how to implement them and what they're actually used for. So normally what you'll see, especially in most modern networks, is that you're going to use a dynamic routing protocol like OSPF or IS to IS. You could also be seeing IBGP. Now, these dynamic protocols are used to share routes and advertise routes from one device to another. That's absolutely fantastic. However, sometimes you'll find that some parts of your network you may not be using a dynamic routing protocol and you'd have to do what's called a static route. So static route is something that's not new in networking. If you've come from the JNCIA Junos, or if you've come from the Cisco world, or in fact any other networking world, you'll be familiar or would have come across static routes. The ability to specifically specify that we want to get from point A, let's say here, to point B here, and it needs to follow a specific path. So in other words, a next hop. So this is how we would do a static route on Juniper. So we would say, let's say this interface here is, let's say this one here is 10.10.10.2 for argument's sake. So this corresponding one would be, say, 10.10.10.1. Okay, let's say we want to get to the loopback on, say, spine 2, which is 22.22.22.22. What we would generally do is that we would say we want to do, under the routing options hierarchy, we'd do a static route to whichever address that we want. Let's say all the twos. So 2222222, say /32. So we give it a /32 subnet, and we'll tell it that the next, there should be an X there. Yeah, let me remove that. Actually, let me just get rid of that there. Where's my rubbery bit on my pen? Okay, that's better. So we will say next hop, and we will tell it where to send the packets of data to. In this case, it would be, let's say, the 10.10.10.2. And then what would happen is that any time in our routing table, if we need to send any traffic to 22.22.22.22, it's automatically going to send it from leaf 1. It'll automatically send it straight to this interface here, and it will allow this device to figure out how to send it. So that's the basics of a static route. We're going to go and have a little look and configure this. I'll have to confirm the actual IPs, to be fair, but let's have a look. Let's jump onto leaf 1 and have a little look. So let's go leaf 1 and let's do a run show interface terse match, just matching inet so I can see what ones are up. So I know it's XE002. All right, so that's fantastic. So we have the address of 10.10.21.2. So that means the other side will have 10.10.21.1. Let's have a quick look at our routing table and see if we have anything in there. So we have our local subnets and what we've got connected to our servers. Okay, so that's about it. So let's try pinging the loopback on spine 2. So let's do run ping 22.22.22.22, and as we see, we have no route to host. So let's set up this static route and see what we can do with this. So let's do a set routing options static route, and now we need to tell it what destination we want the static route to be for. So it's going to be 22.22.22.22/32, and now we need to tell it the next hop, and the next hop is going to be the other end of our XE002 interface. So that's going to be 10.10.21.1. And let's do 10.10.21.1. Sweet. Okay, let's commit that. Just wait for that to go through. Now let's see if we can ping it again now. So let's try pinging 22.22.22.22. And there we go. Fantastic. So we have our static route set up. Let's have a look in the routing table. So if we have a look now in the routing table, we can see that the Juniper device has installed the 22.22.22 static route. We can see that it is static, and we can see that it has a preference of 5. So this is the route preference. So locals and directs, as we can see, have a preference of 0, of course, because they're connected. But a default static route has a preference of 5. So this will beat out any protocol like OSPF, ISIS, EBGP, IBGP, MPLS as well. So it will beat out any other protocol. Static route will always beat it out. However, we can change this particular preference. So we do have plenty of options. So let's go back to our static route configuration. So you see here where we done our set routing options, static route 22222/32, the next hop. If we do a question mark, now we have a lot more options here. What we can look at, we can have things like we can attribute colors to these. So if you're doing things like in MPLS, and you're doing some CSPF, and you're using colors for your interfaces, you can attribute colors to routes, basically like tags in Cisco. You can change the metrics of your static routes as well. And then you have the option of community. So if you want to assign a particular community, a BGP community, to a static route, you can do this. That's absolutely fine. I mean, these options are generally outside of the scope of the normal JNCIA data center. However, you'll come across these if you go a little further, like JNCIS or JNCIP. You have some other options that you'll often find of use is the no re-advertise, which is this one. Now, no re-advertise is if, for argument's sake, we was to use a routing protocol and we would say to it, redistribute static, in other words, to redistribute the static routes that we have. If you put a no re-advertise onto a particular route, then that means that route is not eligible to be advertised into any other routing protocol. You also have things like your resolve. So if the next hop itself has not got the route that you want to go to on it, in our case when we went to spine 2, it has the loopback of 22 ... already on it. However, if we was to want to go to, say, spine 1's loopback address of 11.11.11, but the only option we had is to go to our next hop of spine 2, then we can use the resolve option. So it allows it to attempt to indirectly connect to next hops. I found mixed results with using that, to be honest, in the virtualized environment. That is, on physical equipment, it works absolutely fine. In the virtual environment, it's a bit hit or miss because the way that broadcasts are dealt with via the routing engine and the packet forwarding engine. And then we have our preference. So our preference, well, preference 1, preference 2, but we do normal preference, so you can change the routing preference. So you can make, say, another static route have a completely different preference. Or, for argument's sake, you may want to have, let's say you have OSPF running and you want to ensure that OSPF routes are more preferable over your static route that you put in, because you want your static route to only be a backup. Then you can set the preference of your route to be higher than what the OSPF route would be. So let's change the preference just so you can see it actually changes. One thing we're going to mention as well just after this is the qualified next hop. The qualified next hop is a floating static route in the Cisco terms. So let's do a preference of, let's say, 7, and let's commit that. And now let's have a look at the route in the routing table. So run show route, and let's just do 22.22.22.22. Okay, So you can see here now that the static root now has a preference of 7 instead of a preference of 5 because we've changed the actual static root's preference. Okay, so we've reached just over 10 minutes. We'll end the video here, and in the next one we'll go through the qualified next hop. Look forward to seeing you then.